Good morning. Let us continue this matrix multiplication method, which is our second method to find this DFT. So previously we have seen the direct method which uses that formula, that is x of k is equal to. Now we are going to use this matrix multiplication method. So before going to this, we must find that matrix, how we are using that matrix form. By definition, we know that x of k is equal to, by definition of DFT, we know that x of k, which is equal to summation n is equal to 0 to n minus 1 x of n into e power minus j 2 pi k n by n, where k is equal to 0, 1, 2 and so on n minus 1. So we know this equation. Now what we are going to do is, for matrix multiplication, this x of k, which is equal to, we can write this as wn kn into x of n. So what we have done is, this x of k is equal to wn kn. So this is the wn kn, and here we have x of n, where this wn kn, which is equal to e power minus j 2 pi kn by n, and this is called as Twiddle factor. This is your 2-mark question. What is the Twiddle factor? wn kn is equal to e power minus j 2 pi kn by n is called as Twiddle factor. If we have only wn, then we can write wn will be equal to e power minus j 2 pi by n. This is for DFT. Now if it is IDFT, that is inverse discrete Fourier transform, then we'll have wn power minus kn, because there we don't have minus. So wn power minus kn is equal to e power j 2 pi kn by n, that is for inverse discrete Fourier transform. Now this is called as Twiddle factor. So we are going to calculate matrix multiplication by using this method. Now we have to find what is this wn kn. Now for 4-point DFT, what we have to do is, for 4-point DFT, W4. So here we have W4, because n is equal to 4. Since n is equal to 4, we have W4. So which is equal to, now we have to find the matrix. 4, that is k is equal to 0, k is equal to 1, k is equal to 2, k is equal to 3. We have to find this matrix. For values n is equal to 0, 1, 2, 3. Now what we are going to do is, we are going to calculate for this n is equal to 4. Now write this n is equal to 4. Now write W4. We have to complete this. So W4. W4. Complete this matrix. Since it is 4, we are using n is equal to 4. But if it is 8, then we have to substitute 8 here. Now 0 into 0 is 0. 0 into 1, 0, 0, 0. Because 0 into 1, 2, 3, everything will be 0. Again here n is equal to 0. Now what happens? 1 into 0 will be 0, 2 into 0, 3 into 0. So everything will be 0. Now multiply this. 1 into 1 is 1. 1 into 2, 2. 1 into 3, 3. 2 into 0, 0. 2 into 1, 2. 2 2s are 4. 2 3s are 6. 3 into 0, 0. 3 1s are 3. 3 2s are 6. 3 3s are 9. So this is how we have to calculate the matrix. Now what we have to do is, we have to substitute the values for this W4 power 0, W4 power 1, 2, 3, 4, 5 and so on. Before going to that, now we know, since n is equal to 4, we have n values from 0 to 3, 0, 1, 2, 3. So it is necessary to find only for the values n is equal to 0, n is equal to 1, n is equal to 2 and n is equal to 3. And here we have k is equal to 0, 1, 2, 3. Now what we have to do is, if we find W4 power 0, W4 power 1, this is 0. W4 power 2, W4 power 3. So after this 3, since n is equal to 0 to 3, what we have to find is W4 power 4. So W4 power 5, W4 power 6, W4 power 7. So we have only up to 9. So W4 power 8. Again after this 8. W4 power 9. So this is more than enough to find. Now from this we can conclude this W4 power 0 value will be equal to W4 power 4 and this value will be equal to W4 power 8. So if you find this W4 power 0, then we can write the same answer for this W4 power 4 and we don't have W4 power 8. Then if we find W4 power 1, then it is necessary for W4 power 9. This is 4 and this is 9. Next, if you find W4 power 2, then it will be equal to W4 power 6 since the n value is up to 4. That is 0 to 3. So 0 to 3. After this 3, what happens? Because we know that we have a circle like this. Here we have 0, 1, 2, 3. So after this 3, then this will be equal to 4. Then, and just listen. 0, 1, 2, 3. So after 3, we will have 4, 5, 6, 7. Then 8, 9, 10, 11 and so on, isn't it? Because the circle will rotate like this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and so on. So if you find the value for 0, that will be equal to 4, 8. So no need to find every values. Now we can find the values only for this 0, 1, 2 and 3. Now we can find the values. Now how can we find the values? We know W n power kn, which is equal to e power minus j 2 pi kn by n. Since n is equal to 4, we have to substitute n is equal to 4. And let us take for W4 power 0. Now we can take for W4 power 0, which is equal to, now we can substitute k is equal to 0, n is equal to 0. So we can write e power minus j 2 pi 0 by 4 since n is equal to 4. So we will get e power 0 which is equal to 1. Next W4 power 1 which is equal to, we can take k is equal to 1, n is equal to 1. So substitute e power minus j 2 pi into 1 by 4. Therefore which is equal to e power minus j pi by 2. Now we can write this as which is equal to cos pi by 2 minus j sin pi by 2. Now we know cos 90 which is equal to 0. This is 1. So minus j which is equal to minus j. Now W4 power 2 which is equal to k is equal to 1, n is equal to 2. Now substitute e power minus j 2 pi 1 into 2 by 4. Therefore which is equal to e power minus j pi. Therefore which is equal to cos pi minus j sin pi. Therefore which is equal to, we know that this is minus 1, this is 0. Cos pi cos 180. So which is equal to minus 1. Now W4 power 3 which is equal to k is equal to 1, n is equal to 3. Now substitute this value e power minus j 2 pi into 1 into 3 by 4. Therefore which is equal to e power minus j 3 pi by 2. Therefore which is equal to cos 3 pi by 2 minus j sin 3 pi by 2. Therefore which is equal to cos 3 pi by 2 0, 540 divided by 2 7, that is 270 minus this is minus j. Therefore which is equal to plus j. Now we found out the answer like this. Now what is W4 power 0? So W4 power 0 is equal to 1. So W4 power 0 is equal to 1. What is W4 power 1? W4 power 1 is equal to minus j. Now what is W4 power 2 which is equal to minus 1. Now what is W4 power 3? W4 power 3 is equal to plus j. Now what we have to do is, now write this in the matrix form. Now we have to complete the value. We have to substitute these values in the matrix form. Now what is W4 which is equal to, now substitute the value W4 power 0. W4 power 0 is 1. So W4 power 0 everywhere this will be 1. So 1, 1, 1, 1, 1, 1, 1. So every values will be 1. Now what is W4 power 1? W4 power 1 is minus j. W4 power 2. W4 power 2 is minus 1. W4 power 3. W4 power 3 is plus j. Now what is W4 power 2? What is W4 power 2 is minus 1. 4 power 4. W4 power 4 will be equal to 1. W4 power 6. W4 power 6 is equal to minus 1. W4 power 3. W4 power 3 is plus j. W4 power 6. W4 power 6 is equal to minus 1. W4 power 9. W4 power 9 is minus j. So this is how we have to calculate this value. So 1, 1, 1, 1 minus j minus 1 plus j. Then here we have 1 minus 1 plus 1 minus 1. Here we have 1 j minus 1 minus j. So we have computed W4. That is for 4-point DFT. We know the matrix Wn power Kn. Now what we have to do for finding 4-point DFT using matrix method, we must use x of k, which is equal to Wn per kn into x of n. This will be our question, the values which is present in the question, and Wn power kn, just now we found Wn power kn is equal to, this is the value for that. Now let us move on to the problem. Now calculate the DFT of the sequence x of n is equal to the same numbers we are solving from the beginning. For DFT direct calculation, we have used the same value 1, 1, minus 2, minus 2. And for calculating the IDFT, we have taken the answer of this as a question and we have found the answer 1, 1, minus 2, minus 2. Now what we are going to do is, we are going to calculate the DFT of the sequence x of n, which is equal to 1, 1, minus 2, minus 2 by matrix method. Now what we have to do is, for solving this by matrix method, we know the question is given as x of n, which is equal to 1, 1, minus 2, minus 2, and already we know that xn, which is equal to, what we have to do is wn into xn. Now we know that x4, because it is 4-point DFT, which is equal to w4 into x4, the sequence. Now we can find x4, which is equal to, what is this w4? Just now we have calculated this w4 will be equal to, now copy this, 1, 1, 1, 1, 1, 1, 1, minus j minus 1 plus j minus 1, 1 minus 1, j minus 1 minus j. Now do matrix multiplication. What is this x of 4? X of 4 is this question, that is 1, 1, minus 2, minus 2. So this is from the question 1, 1, minus 2, minus 2. Now do this matrix multiplication, which is equal to, we know that it is row into column. So 1 into 1, next 1 into 1, 1 into minus 2, 1 into minus 2, minus 2. Now 1 into 1. Next minus j into 1, minus j. Minus 1 into minus 2, that is plus 2. J into minus 2, minus 2j. Next 1 into 1, minus 1 into 1. 1 into minus 2, minus 2. Minus 1 into minus 2, plus 2. Next 1 into 1, 1. J into 1 plus j. Minus 1 into minus 2, plus 2. Minus j into minus plus 2j. Now we have to calculate this. 1 plus 1, 2, minus 2. So plus 1 plus 2. So it is equal to minus 2. And here we have plus 2 plus 1 is 3. 3 minus 3j. Next 1 minus 1 minus 2. So here we have minus 3. Sorry, minus 1 minus 2. So this is 0. Now it is plus 3 plus 3j. Therefore the answer is x of k is equal to, what is the answer? Minus 2, 3 minus 3j, 0, 3 plus 3j. Actually this is the answer which we got in the direct form also. This is how we have to do this 4-point DFT by matrix method. Now I hope you will understand this. Whatever it may be, the numbers, we have to use the same matrix form. That is W4 for a 4-point DFT, we have to use the same matrix form, and here you have to substitute the numbers. If we have 1, 0, 1, 0, then you have to put 1, 0, 1, 0. If we have 0, 0, 1, 1, then you have to take 0, 0, 1, 1 here. then do the matrix multiplication, finally you'll get the answer. So this is easy when compared to that matrix method, that is previous direct method where we have to substitute the values. And both are easy, but comparatively this will be very easy for you. Hope you'll understand this. If you like, share and support. Thank you. We'll meet soon in the next video.